Okay, many people have trouble programming their VCR, so a company has developed what it hopes to be easier instruction. The goal is to have at least 96% of customers succeed. The company tests a new system of 200 people, of whom 188 were successful. Is this strong evidence that the new system fails to meet the company's goal? Okay. And then a student's test of the hypothesis is shown below. How many mistakes can you find? Okay, well, let's go through this. So, problem one, the null and alternative hypothesis should be in terms of p, not p hat. Okay, so that's problem one. You should have p equals 0.96, and this should be p on the bottom. Problem two is, the question is this strong evidence that the new system fails to meet the company's goal? So that means that our alternative hypothesis should be p is less than 0.96. Okay, so the alternative hypothesis not only should have p, but it should be p is less than 0.96. Okay. Third problem is the conditions. Okay, they did not put the independent condition that it met the independent condition. Okay, 100 out of the responses, each person's ability to follow the directions should be independent. There's nothing that says it's random or representative. Okay, all it says is SRS. Okay, but this should be a representative sample. Okay, and then this is the success failure condition. 0.96 is times 200 is greater than 10, but they forgot to put the failure part. So 0.04 times 200 is 8, and this actually would be less than 10. So 0.04 times 200 is 8, so it fails the success failure condition. Okay, and they also did not put the 10% condition. Okay, and that's that 200 people is less than 10% of all people that should be able to program a VCR. So that's mistake number 3, the conditions. Okay. Okay, so what this is, we don't know. I'm assuming this should be p hat equals 188 over 200. They didn't put that. Standard deviation is never in terms of p hat. Okay, so the standard deviation should be in terms of p and q, not p hat and q hat. So the standard deviation of p hat, or the standard deviation of p, should be the square root of 0.96 times 0.04 over 200. Okay, and if you do that, you get about 0.014. Okay, you get about 0.014. So this should be 0.014. So then z should be 0.94, which is p hat minus p over the square root of pq over n, which is 0.014. And if we do that, we get like negative 1.43, right? And then we should be doing, okay, so p is 0.96 and negative 1.43 is like over here. This is actually z equals, and this is actually z equals 0. And we should be finding that area, right? So our p-value is going to be norm CDF from negative 99 to negative 1.43, and you get like 0.08, okay, 0.076. So that's wrong. Okay, so this piece right here is wrong. This should be z is less than negative 1.43, and it's 0.076. And then the conclusion, there is strong evidence that the new system does not work. That is wrong also. The conclusion should be, since p is 0.076, that there is no evidence that the new system has failed to meet the goal. Okay, so we would not reject the null. Remember, our null was p equals 0.96, and the alternative was p is less than 0.96. So we cannot reject a no. So there is no evidence that P does not equal 0.96. So again, the conclusion is no evidence the new system has failed to meet the goal. Okay.